So 6-3, we're concentrating on adding, subtracting, and multiplying polynomials. We're going to do 6-3, then 6-1. We're going to have Fun Wednesday, and we'll go on from there. So just so you know, this could be written vertically or horizontally whenever we add or subtract polynomials. But so the bad thing about your guided notes is these examples are written uber small. That's the bad thing about these guided notes. But anyway, when we add or subtract polynomials, we're just going to get like terms together. Most of you saw this on the pre-test. Why don't you go ahead and do it? See if you can figure out the like terms and check with my answer above. So in the first example, if I'm taking 3x squared plus 2x squared minus x minus 7 and adding x cubed minus 10x squared plus 8, I just get like terms together. 4x cubed minus 8x squared minus x plus 1. And the next one, this is what your homework's going to look like. This is typically what SAT looks like and so forth. You have to be aware, if you are subtracting, you have to subtract the entire second set of parentheses. Be sure you distribute that negative sign first. That might be the hardest thing today. Answer becomes 2x squared. No, silly me. Negative x squared plus 2x plus 4. So I'm going to attempt the vertically written. This is where you again stack terms or like terms on top of each other, but similar to how we multiply 2-digit, 3-digit numbers. I'd probably multiply -3 times each piece first. So I get -12, -6x, positive 3x squared. And then I'm going to multiply x times each term. So I get 4x. And as I write it below, there's still like just similar, there's a 0 as a placeholder in the last column, and then you get 4x plus 8x squared minus 3x cubed. And then you add those columns. Sometimes it is helpful to stack these on top of each other. Sometimes it's more work than needed. Had a good question. I'm going to repeat it. Asked about this x. Do we do anything with it? This is supposed to just be the multiplication sign, so we're not going to touch it. Let's go to the next example. Distributing x minus 3 throughout the second set of parentheses. So we're going to take x and distribute it. And then if you take the -3 and distribute, I'm going to show that in red. And then so -6x cubed. No! Whoa. 3x cubed minus 11x squared plus 2x plus 12. We've already talked about the sum and difference. Like if you have a difference of squares, it factors into the square roots, the sum of the square roots and the difference of the square roots. But what we're going to look at is if we notice that the same thing plus something is being multiplied by the binomial with the minus sign in it, it's just going to turn into a difference of squares. If you square a binomial, you could look at it as it's going to turn into the sum of the square of the first term plus twice the product of these two times each other plus the square of the last term. Anyway, these are just if you want to memorize. Some of you are asking about next year. Hey, what are we going to look at in discrete, in trigonometry, in whatever? If you took trigonometry or discrete for next year, you will still cover this cubes, these in more detail about the pattern with it. You actually will also talk about it in statistics, but in a different format. It deals with probability, those squares of binomials, cubes of binomials. All right. I'm not going to make you memorize it. I'm just going to tell you that there are patterns to these special products. So here we go. All right, so the first one, if I'm trying to use a shortcut, I notice the first binomial has a minus sign, the second binomial has a plus sign, so it's going to be a difference of squares. Square of the first term is 16n squared minus the square of the second term, 25. If you completely distributed all those terms, you get 16n squared minus 25. Let's talk about what happens when you take 9y minus x squared times itself. So recognize that is multiplied by itself. I have a feeling a lot of people are going to guess 81y squared plus x to the fourth, which is not the case. It's going to be 81y squared minus 18x squared y. There's going to be some sort of middle term in there because you'll have minus, you'll have minus 9x squared y minus 9x squared y and then plus x to the fourth. Let's multiply 2 at a time. So this is what I'm going to expect in homework. Multiply 2 at a time. These two multiplied by each other turn into, so the first two multiplied by each other and simplified. Now I'm going to completely distribute into the last AB plus 2. This term, 4a squared b squared, comes from 4ab times ab. So then if you take 4ab times 2, you're going to get 8ab. Then I'm going to look at the 4. Take 4 times ab, 4 times 2. This is where we're stepping it up when we distribute something 3 times. But we're not done. We've got to write it as a simplified answer. Simplified answer is a cubed b cubed plus 6a squared b squared plus 12ab plus 8. So, homework. Page 341, numbers 13 through 61 multiples of 4. Happy New Year. This is how homework's going to be. Multiples of 4. So no, 13 is not a multiple of 4. So you're going to start at 16. Woot woot.